Today we'll discuss all those GATE questions based on Phi Index. So before solving the questions, let us again discuss that one thing. What happens if rainfall occurs? Rainfall occurs, that means I have to draw a hydrograph. What is hydrograph? Hydrograph, it's a graph between intensity of rainfall with respect to time. So corresponding to intensity values, I have plotted a hydrograph. Then what happens? From that rainfall, I want to calculate the effective rainfall. Effective rainfall means runoff. For the calculation of effective rainfall, at first I need to locate one line, that is average infiltration rate. What I have taught you in the quick revision of infiltration, there are two average infiltration rate, infiltration indices. One is Phi Index, another one is W Index. It is impossible to calculate W Index as it includes initial losses. That's why all the GATE questions are from Phi Index only. So this line is known as average infiltration rate line, and I am writing as Phi Index. So above this line of Phi Index, whatever I got, this is runoff, and below this line there is no runoff, that is also known as infiltration. If I got any value, on this line, if I got any intensity value of this line, suppose if I got an intensity value on this line or on this line, that means these values will also have no runoff. Just remember that above this line there will be runoff, below this line there will be no runoff. What I have taught you, Phi Index equal to PE minus R divided by TE. What is TE? TE I have taught you, this is time of excess. Time of excess means the time during which there is runoff. So Phi Index is based on PE minus R divided by TE. TE is known as time during which there is runoff, and PE is rainfall corresponding to TE value. So we need these concepts for the solving of the questions based on Phi Index. Now it's time for solving the questions based on GATE. So we'll solve the 1 mark question asked in GATE 2017. So simply pause the video, try the question yourself. So this is the very easy question. If you just see the graph and you can find the answer. In the question he has mentioned that during a storm event in a certain period the rainfall intensity value is given. So what he has done, he has given the intensity value as 3.5 centimeter per hour, and the Phi Index is 1.5 centimeter per hour. Phi Index is 1.5 centimeter per hour. What is he has asked the intensity of effective rainfall. What is effective rainfall? I have told you, effective rainfall is nothing but runoff. Effective rainfall. So intensity of rainfall is given and the value of the Phi Index is given. So above the line, what is there? That will be runoff, that is effective rainfall. So what I can write, effective rainfall or runoff equal to I minus phi. So this thing you can write on your short notes. So what is intensity? Intensity value is given as 3.5. Then the Phi index value is given as 1.5. So 2 centimeter per hour. So very easy question. So this is the question asked in GATE 2004. It's a 2-mark question. It's a very important type of question. That's why I have decided to solve this question. Please understand this question. All those concepts are very important, and rest questions are based on the concept behind this question only. So let us solve the question. So the question states that the rainfall during 3 successive 2 hours period. 3 successive 2 hours period means the hours is, the first successive 2 hour is 0 to 2, the second successive 2 hour is 2 to 4, the third successive 2 hour is 4 to 6. So I can write that time in hours, that is 2, 4 and 6. Next, the rainfall values he has given. Rainfall P in centimeter. What he has given? 0.5, 2.8 and 1.6. So he has also given the runoff value. So runoff R equal to 3.2 centimeter. He has asked us to calculate the Phi index. So he has given the time value, he has given the rainfall value, but he has not given the intensity value. So we have to calculate the intensity value. So intensity, that is centimeter per hour. So what I have told you, intensity I equal to P by T. So for first case, so precipitation is 0.5, time is 2 hours. For this case, I equal to precipitation 0.5, time is 2 hours. So I equal to 0.25. So I can write it as 0.25. So for second case also, 2.8 divided by 2, time is 2 hours. 2 to 4, it is 2 hours, the second successive hours. So 2.8 divided by 2, that is 1.4. Next, 1.6 divided by 2, the intensity value for the third column will be 0.8. Now it's time to calculate Phi index. So what is Phi index? Phi index equal to PE minus R divided by TE. So what is TE? TE equal to time of excess. So time of excess. So what is time of excess? Assume time of excess is 6 hours. So assume time of excess equal to 6 hours. Why we are assuming it? Because we are not sure whether it's a correct Phi index or not. Where if rainfall intensity value is below that Phi index line or not. That's why at first we need to assume the time of excess value as the total time value. So we have assumed the total time value, that is 6 hours, and PE. What is PE? PE is rainfall corresponding to TE. So my PE will be, for 6 hours I have to add all those precipitation values, that is 0.5 plus 2.8 plus 1.6. if you just calculate it as, that will be 4.9. So this will be 4.9 minus 3.2, that will be 1.7 divided by 6. I think that is 0.283. So I have get the Phi Index as 0.283. If this is a correct Phi Index or not, this thing I have to check. How to check? So I have told you, if this is the intensity, centimeter per hour, and this is time, and I have calculated the Phi Index as 0.283. So for the first column I have to check the intensity value. You can see for this first column is 0.25. So this is 0.25. For the next column you can see the intensity value for the next 2 hours, that is 1.4, that this is 1.4, and the next last value you can find as this is 0.8. So what you can see, that the 0.25 value is below the line of Phi Index. So our assumption is wrong. We have assumed that the time of excess is 6 hours. What is time of excess? Time during which there is runoff. So you can see that there is no runoff for the first 2 hours, because for the first 2 hours the intensity value is lie below the Phi Index line. So our assumption is wrong. It is not correct value. Assumption is wrong. Correct time of excess value equal to 4 hours. So please note this thing. After you note this thing, we will move to the next step, finding the Phi Index. So we have done our first trial. On our first trial, we have find the Phi Index line, and we have calculated the Phi Index line as 0.283, and what we have find that the during the first 2 hours there is no runoff. So there is no runoff. The intensity value is lie below the Phi Index we have calculated. We have calculated the Phi Index as 0.283, and the intensity value we have got, that is 0.25. This 0.25 intensity value is below the 0.283 line. That's why we have found that for the first 2 hours there is no runoff. That's why the obtained TE is equal to 4 hours. So again we need to calculate the Phi Index in our next trial. Again the Phi Index equal to PE minus R divided by TE. What is TE? Again TE equal to time of excess during which there is runoff. PE is rainfall value corresponding to TE value. So TE is 4 hours. What is PE? PE means I have to add 2.8 plus 1.6 only. I can't add 0.5 because in this there will be no runoff. So this precipitation value is corresponding to time value. This precipitation value corresponding to time value. So what is my PE? So PE will be 2.8 plus 1.6. So this is 4.4. So again 4.4 minus runoff. Runoff is given as 3.2. So if you just calculate it, is 0.3. Now again we can check, cross check whether this value is correct or not. That's why I can write as intensity centimeter per hour. This is time in hours. So this line I have got it as 0.3. This is the Phi index value. I have got it as 0.3. Now I can check. I can check the first thing we have eliminated. So in the next trial, the intensity value of 1.4. So 1.4 is above this line. Next 0.8. 0.8 is also above this line. So our assumption is correct. Assumption of T equal to 4 is correct. So we have got our answer. Phi index equal to, for this question, equal to 0.3. So please note it down. I hope you have understood this question. If you have not understood, I hope you can watch the quick revision of infiltration and again play this video. So please, this is the important question. All these questions after this based on this concept. Please note it down. So this is the question asked in GATE 2007. It's a 2-mark question. Here in this question, what he has done, he has given the time interval of 4 hours. In that 4 hours, he has given the corresponding rainfall values. For the first hour, he has given the rainfall value as 9. For second hour, 28, third hour, 12, and the final hour, fourth hour, it is given as 7 mm. So he has given the rainfall values corresponding to time interval of 4 hours, but he has not given the intensity value. So what we need to calculate the intensity value first. So what is intensity? Basically intensity is centimeter per hour, but in this question he has given the rainfall value in mm, so I can write as intensity is mm per hour. So what I need, intensity I equal to P by T. Again the same formula is used everywhere. Time interval of 1 hour. So P value is 9. 9 by 1, that is 9. So in each hour it is 1 hour. So for the second hour is also 1 hour. So again 28 by 1, 28, 12 by 1, 12, 7 by 1, 7. Then in the question he has given the Phi index for the catchment is 10 mm per hour. He has given the Phi index as 10 mm per hour. He has asked us to find the runoff depth. Means in this question he has given the Phi index value and he has asked us the runoff. So at first we need to cross check. So in our first trial, so what we can see, this is intensity centimeter per hour. This is time in hour. So he has given the Phi index value as 10 mm per hour. For the first interval, for the first hour, he has given the intensity value as 9. So this is my 9. For the second hour, the intensity value is 28. For the second hour. For the third hour, the intensity value is 12. For the fourth hour, the intensity value is 7. Below the line, this is 7. So what I have told you, so for the first hour and in the last hour, the intensity value is below the calculated value of Phi index. So intensity value below the Phi index means there will be no runoff. So that runoff value will be, so I can write that Phi index equal to PE minus R divided by TE. What I have told you, what is TE? T is time of excess, time during which there is runoff. So for the first hour there is no runoff, for the last hour there is no runoff. So my corresponding obtained TE value is 2 hours. 2 hours. What is PE? PE is corresponding to TE value. So what I can write? I have to add the PE value only 28 and 12, though the first value and the last value is below the Phi Index line. So my PE will be 28 plus 12, that is 40. So PE 40 minus R I have to find. So what is Phi Index? Phi Index he has given as 10 mm per hour equal to 40 minus R divided by 2. If you just found, you can find runoff as 20 mm. So I hope you have understood this question. Please note it down. After note it down, you can solve the next question. That's an easy question. So this is the question asked in GATE 2013. It's a linked answer type question. It's a very easy question, and you can see that it's a question of 4 marks, means 2 plus 2, 4 marks. If you can find the answer of the first question, you can find the answer of the second question. So easy question of 4 marks, and the question state that storm 1, he has given storm 1 and 5 hour duration, means time of excess TE value he has given as 5 hours, with intensity he has given intensity equal to 2 centimeter per hour. Result a runoff is 4 centimeter. Then he has given the second storm 2. Storm 2 of 8 hours, time of excess T equal to 8 hours. Runoff he has given as 8.4 centimeter. What he has done, he has told us that the Phi Index is same for the both the storms, and in the first question he has asked us to calculate Phi Index. So what is Phi Index? Phi Index equal to PE minus R divided by TE. So how to calculate PE? So again the same formula, intensity equal to PE by T. P by T. So intensity equal to 2. P I can find, time is 5 hours. So what I can find? P equal to 2 into 5 equal to 10 centimeter. So P equal to 10 centimeter minus runoff he has given as 4, time of excess 5. So 6 by 5. What is 6 by 5? 1.2. So the first answer of this question is 1.2, option A. And he has told us that the Phi Index is same for both the questions. So in the second question he has asked us what is intensity of rainfall. Again the same formula, Phi Index equal to PE minus R divided by TE. What is PE? PE I don't know. So I have to calculate PE here. What is runoff? Runoff is 8.4. What is time of excess? T equal to 8. What is Phi Index? Phi Index I have to take from this question, that is 1.2. So just simplify that. The precipitation value we can get after the finding the precipitation value, you can find the intensity value. So what is the precipitation value you can get? You can find as Pe equal to 18 centimeter. So I know intensity I equal to Pe by T. Pe by T. So what is Pe? Pe equal to 18 centimeter. What is my time? Time equal to 8 hours. So just simplify this. You can find as 2.25 centimeter per hour. So please note it down the question, and the option is D for this question. Very easy question. I hope you have understood this thing. Please note it down. So we have solved all those questions asked in Phi Index apart from one question, that is GATE 2019 question. What I am going to do, I am giving you this question as homework because I just want to know how many of you are able to find the answer of this question. I will solve this question on this next video, but I am giving you this question because it's a very difficult question. Not difficult because it's a difficult in concept, because you need a calculation for this question. In GATE exam, the examination is of 3 hours at least. If you are able to find the answer within 5 minutes, means it's a bonus for you. So I just want to give you this question. Please solve this question and comment your answer on this video so that I can know how many of you are able to find the answer. So what you can see, he has not given the Phi Index line as a straight. You can see he has given the Phi Index line as shown in the graph. So above the Phi Index line there will be runoff, below there will be infiltration. And please try this question yourself, and I will solve this question in the next video. Thanks for watching this video. We'll see in our next video.